Welcome back. In today's episode, we are going to use Power Apps to search relational lists in SharePoint. Good morning. So, funny thing happened on the way to this episode. I had another one planned, and at work, I had an interesting ask that turned out to be something that I thought would be worth sharing today. The ask was, within the Power App I was building, I had a collection of lists that were joined relationally like a database. And the user had wanted to search these lists where they wanted the content of the relational lists to affect the main search results on the main record. And at first, I didn't know how to do it. So I thought about it and came up with what I consider a relatively novel solution that I wanted to share with you today. Now, before we get started, for those of you who don't know, I want to go ahead and go over what a relational list structure looks like in SharePoint. What we're doing is essentially creating a simple database table collection within SharePoint. And many of you who are building Power Apps using SharePoint Online as our data source have done this. So what we have is, as we see here, some main record. You could look at for what we're going to do today. We're going to build sort of an online magazine. And our main record, you could look at it as the issue itself. And within an issue, you would have several items that would all relate to the main issue. So for example, you could have articles, you could have advertisements, which is what we do. And what that will all relate to is one big collection of things, but it results in what is called a one-to-many relationship. And we see that here, where our main record exists as the issue itself, and then we have different categories of uniquely defined data types that could have multiple copies within. So our main issue, for example, may in the green have 3 articles within that issue. We're going to have advertisements in our other example, so that could be the other category here. And maybe we even have some third collection of data. You can have as many as you want, but the main idea is each of these sub-items are unique to each other, but all relate to each other as having one common parent. So that's what we're going to put together today. And the main problem we're going to solve is, how does one search within Power Apps these sub-records, but yet still return the main record? So it's like, I want to search articles for certain content, but what I really want in my search results is the individual issues to come back. And that's what we're going to solve today. So looking at our Power App, I'm going to show you what it is we're going to build first. And as we see here, we have a gallery, text box with search, a search button. And what we would do, so if we typed in SharePoint and hit search, it's going to think a moment, and we're going to bring back results of issues. So we see here that both of those create one each. We do YouTube, that's obviously in issue number 2. And so you get the point. We can do a quick refresh. Now, we see here I do have raw data, so you can see I have articles here that come back in search. And what we're going to do is we're going to combine all of our sub-item list into one big list, one big gallery right here that gives us our issue search results. So how are we going to put that together? Now, the first thing I want to show you before we get into how this is put together is let's go through a quick example of how search itself works in Power Apps, all right? Because that's important to give some background. We can, of course, see here as you type in, that one is not there, episode. So you can see as we type, we have search results. Now, how does that work? If we go to our gallery, we see we have our search function outlined here. Search requires a data source. In this case, I have a list, which is called issues, and I'll show you how my data is put together in a moment. You have input for what your keywords are. In this case, that is this search box here. And then you have the columns that you want searched. And these represent the internal names, in terms of SharePoint, the internal names of the columns that we want to focus on in terms of our search results. So what we'll see here and how this is reflected, if we look at our list, we see we have an issues list. We have title. Now, for me, I never use title as interesting data. I always use title to showcase what the item is, mainly because the title column just does so much. It's the clickable link for details. It's only worded title. You can't change the internal name. And so for me, this is almost a throwaway column in every list I build. But in this case, it could be useful because it at least defines what it is we're doing, and you'll see how that comes into play later. Of course, we have our ID column, and we have two data columns here, issue title and headline. So now if we go in and look at the structure itself, we will see how the list was created. So we see we have issue title and headline, and those are nice display names. But if we look down at the bottom here, we see that the internal name I have labeled as ISS issue title and ISS headline. ISS for issue, which reflects the list that I'm in, and then a non-space version of the field name. Now, I've done this forever. This goes back to using search with SharePoint 2013. As you needed crawled properties, they had to be unique, at least for me, so I could find them. So just having issue space title, outside of as a developer having a space in the title, could get a bit vague, especially as you have hundreds of people using SharePoint, each creating their own columns. I wanted to make sure what I was doing came across as unique. And so I got into the habit of creating my lists such where the internal names all reflected the list that they were in. Now, our sub lists that we're going to use, we see here I have an issues article, and it has, again, title, and you'll see here I just have it listed as what it is, so I have article. And I have a column related ID, and this was the foreign key relationship as hinted at earlier in the PowerPoint presentation. This field has the ID of our issues list. So we have issues ID 1 and 2. The articles are related that way. So that gives us our primary foreign key relationship. And from there, I have a body and a headline. So, nothing fancy. We're just doing an easy example here. But to show you, again, related ID. Now, we'll start with body. ISS ART body is the internal name. So issue article body, and then issue article headline, because headline would be repeated otherwise. But if we look at related ID, now I don't name this one uniquely. I don't have the prefix here, because this is going to be a common column amongst all of my lists, and there's absolutely no reason why this would be a searchable column. There just isn't. I mean, it's a unique ID essentially. No one's going to know about this ID. No one's going to type 2 in order to see something. So in this case, I'm using a common related foreign key here internally, so it would be universal throughout my sub lists. And we'll see here in our want ads, we have a title again, related ID, and a subject and a body. So the data columns are going to be unique because, again, each individual sub item is in itself unique. And that's kind of the reason why they exist this way. Otherwise, we would just have one big list. And just for the sake of completeness, we're going to come in here. We see we have related ID. And this, again, is not prefixed. But if we go to add subject, we see ISS WA subject, if you can see the bottom of the screen. And the same with body. So we've named the data fields uniquely, and that'll help with our search function because we want to be able to point out what it is we're searching when we use the search function. Okay. Now that we have our data established, let's go back and see how the Power App works. So what we want to put together here, we're going to start with kind of a bare bones approach. And what we have here is we have a gallery. Right now that gallery is blank. I just kind of did the basic stuff early so you didn't have to see me drag and recolor a whole bunch of stuff here. But the idea is we're going to populate this gallery with our search results. based on this search box, and we have a search button. Now, this is kind of the first departure we're going to have from a traditional search. If we see in our example, search is live. So search, you see it comes to 1, YouTube. So as you type, normally now, if we do a gallery with the search function, it is live based on the current state of the text box, because it's just the way the gallery is defined. Now, we're not going to have that here. You could probably do that, but there's going to be a lot happening, and so it starts becoming really inefficient to have it live. So the first concession we're going to make is that we now have a search button. Now, if you want to put it on an icon in the box, you click the magnifying glass. However you want to do this is up to you. I'm going to put it in a search button so we can see how the functionality works. However you want to customize it is up to you. So let's go ahead and establish what it is we're going to do. Now, the secret here, I'm going to go ahead and show you how it's all put together. So this is our working version. And if we see here, so if you want to just stop the video right now, stop it right here. This is how it's put together. Is that we are going to put all of this in one main collection and have that be what our gallery shows. So all of our search functions are going to feed collections, and those collections will then give us search results. So the idea is we're going to have 2 collections that we're going to build. The first collection is the one that will hold issues. So this is essentially our final results collection. So the end of all issues that we want to search. As an intermediate, we're going to have a second collection, and that collection is going to contain the detail lists search results. So in this case, the articles and the ads are all going to be funneled into a second collection, which we'll then process and put into our main collection. Okay? So let's put it together. So we're going to come here, and everything goes in our on select. So the first thing we're going to need to do is, again, we have to establish our main collection. And we know our results are all issued. So keep in mind, this is our search button. What we need to do first is soups. So we're going to have... So we're going to establish our collection first. And what's going to be in that collection? Now, in order to get our structure right, we want it to contain our issues list. So normally we would just do, call collect issues, but we're searching. So we're going to add to our collection the end results of a search function of our issues. We are going to use text search main .text. So we see here on the left we have our text box, and in that we're going to add our columns. And as we noticed before, now IntelliSense is a beautiful thing. So we see here we have issue title and issue headline. We're going to end that semicolon. So what have we done? We are going to, again, populate an issues-based collection, and we're just going to search the main fields within our main list. So we're kind of establishing if the search results comes back with the issue anyway, let's go ahead and put that in. If it's blank, we're fine because we've at least established the structure of our collection. Now we can use it. Now you will see a delegation warning. This is just the fun of doing search on different types. So when you get to multi-line versus single lines of text, of course, multi-lines are inefficient, and you're going to get the warning about large data sets. It's not the most efficient thing, obviously, because we're just doing multiple search calls. You're just going to have to weigh the advantages of a solution like this if you need it versus the potential on a delegation warning. And just see if it works or doesn't work based on your data. But for today's example, we're going to prove how we do it, refining it to not have delegation. Well, we're not going to worry about in this particular episode. So now that we have our search results defined, we can come to our gallery and establish that as our data source. What we're going to need, we'll drag in real quick. So this item, what is it? Issue title. Give it some space. We'll do another one. And we'll do headline. There we go. So now we'll at least be able to see the data as we go. And now I'm going to go ahead and put in here, just so we can see it, the ID. Just so we know what issue is coming back. Okay? Of course, we do this properly, we're going to rename them, but we're going to leave it like this for right now. If we come back, now of course we should be able to see, I can't remember if SharePoint was one example, we're going to think, that apparently was not. YouTube should have one that comes back, and search comes back with issue 1. So we see that we are working. All right, and blank, of course, with search returns essentially a wildcard, so we see both of our issues. So we know that search works, but all that gives us so far is issues. We have not searched our subs. So this next section is essentially the interesting part of this video. When I was figuring this out, I had to think about it. I really didn't know how this would work, and because the search function itself returns the table. And I remember doing something similar to this in a different project, and I remember that collect as a function has the ability to have multiple tables added within. So collect, give me a collection, and then you can stack beneath that within one command different records. And I was like, well, that's what I need. And so I was wondering if it would work with search functions, and obviously because we're doing this, it does, but it was a pleasant surprise. Now, so what we're going to need to do then is establish ourselves another collection, call, and this is going to be the details that we're going to have. And within that, we're going to search our articles. We are still going to keep text search main.text because that is our text box on this page. So we're going to feed the same text box in all of our search results. So again, this is our central one-stop shop for searching. And from within here, issue article body and issue article headline. So if we stopped right here, we have a collection of just our articles, but we can stack here, issue 1 ads, learn to type too. There we go. Histoire. Oops. What did I do? Histoire subject. And I believe Histoire body is what I need to do. Yes. So we now have a collection, and it combines these two search functions. Now, as we saw before, and as we can easily see right here, the structures of these are not the same. And so what does a collection do with this? Because it's obviously not going to be one-to-one throughout. And that's the beauty of Power Apps collections, is that they're flexible. If the columns do overlap, so we have title and related ID, well then those remain as common within the collection. But for any unique column, from one search result or one data source to another, it simply adds it as other columns within the collection. So isArt body and Histoire subject are all common on every record in this collection. They'll just be blank based upon this particular return result. So we have now just a wonderfully flexible collection that has end search results of our articles and our want ads. Now we could see that if we wanted to by coming in here, and what if we added a gallery? Let's give it a little breathing room. And if our data needed to be our detail search results, what we could do now is come in here and we could see title, for example, because that's common. And we'll do a little combination here. Related ID, again, the two common fields. So if I wanted to say search for SharePoint, we see here we have two want ads with SharePoint. Give it a little space. And if we go to our want ads list, we see within the body we should have SharePoint and SharePoint. So article IDs 1 and 2 should come back, and want ad 1, want ad 2. And so they did. What do we do with this? Now you can see SharePoint did not return a result in our issue. So the next step we have is combining the information in our detail collection with our main collection. And so now we're going to have to loop. So you can see here again, this is why the live as you type search really isn't effective, because there's a lot happening here, and I think the lag you would see if you could rig this up as just straight up collection would just be way too much. I mean, you could do the on change event in the text box, but again, you're not. I just think you're going to see so much of a lag, especially on larger data sets, that your user experience will go downhill really quick. So one search button, even though it may take a little longer, would give a more proper end result. No. It's up to you, but again, we're going to do this example because I find this to be the best of what I have found. So how do we combine them? So we're going to loop through our collection. So we're going to go for every detail. Now what we want to do here is, if the main collection already has a record in place for an issue, we're not going to re-add it. But if it doesn't have it, we want to make sure we add that article, that issue, into our main collection. So we're going to loop through the details, and now in order to check if it's there, of course, we're going to have to do our is blank. So if is blank, look up in our call main search results, the ID equals search. I like to do an as because that gives me something tangible that I can use. It's nice to see visually what's happening here. So we're going to say if we're blank looking up in our main collection where the ID of the main issue is equal to our foreign key related ID. If that's blank, we're going to add. So if it's blank, we're going to collect call main search results, and we're going to input. We're going to look up, in this case, we're going to look up the issue and use our same ID equals search result.id. There's our if, and there's our for all. So recapping, we're going to take our details. If we are in our main, we don't already have the issue there, we're going to add it. And that'll give us one main collection, which we've already established, that has all issues where any subdata that might exist has been placed. So let's see how that works. Yeah, so it wasn't working, and here's why. I had a bit of a typo. Notice here I had done a semicolon which ended the statement, a comma must be there as our sequential list. Okay, so as we see now, as we go through in our list, if we search SharePoint, we see we have articles with their article ID and their articles in want as with their issue ID, and we see we have 2. We look up Power for Power Apps. Again, there's only an article, but Power Apps and Coffee is in both issues. Look up the word Relational. Now, it is not in an issue title, but it is in an article, and that article now appears in search. So we have accomplished our goal of having a unified search button and multiple one-to-many lists all feeding into our main search results. Now, where you go from here, you could of course have your search results customized however you need to, but fundamentally this is how we get that data combined and put into one unified search. Thank you again for watching. I'll see you again next time. Have a good one.